আসসালামু আলাইকুম এভরিওয়ান। তো আজকের ভিডিওতে আপনাদেরকে দেখাবো আমাদের ফাস্ট মেমোরি অনেক দ্রুত ভেরিফাই। এই জায়গায় একটা রিয়েক্ট দিবেন, তাহলে সব চ্যানেল আনলক হয়ে যাবে। দেন ভিডিও রিসোর্সে যে এই চ্যানেলে জয়েন হবেন, চ্যানেলে জয়েন হওয়ার পর ভিডিও রিসোর্সে সব কিছু পেয়ে যাবেন। সো অ্যাড দিবেন, পেডটা আপনাদেরকে আমি দিয়ে দিব, এই যে নোট পেডটা এবং উপর থেকে। আর আরেক কথা, আমার এমন না যে যেটা হলো কি হতো, জাস্ট কত সেকেন্ড লাগে জাস্ট দেখেন। এই যে জাস্ট একটা লেখ, দেন হয়ে গেছে। দেখছেন কত তাড়াতাড়ি। এখন আমি স্নাইপার সুইচটা দেখাচ্ছি জাস্ট। এই দেখেন অ্যাপ্লাইং, এই যে কত ল্যাগ দিতেছি, ল্যাগ দেওয়া দেখেন এখনো স্টার্ট হয় নাই। সো কতক্ষণ লেট হয়েছে। এখন আমি ল্যাগ ফিক্সটা বলতেছি, ল্যাগ ফিক্স কিভাবে করবেন আপনারা, ল্যাগ ফিক্স কিভাবে করবেন। সো ল্যাগ ফিক্স করার জন্য আপনাদের যেটা করতে হবে, টাস্ক ম্যানেজারে ঢুকতে হবে। ফার্স্ট অফ অল টাস্ক ম্যানেজারে ঢুকবেন, ঢোকার পর ডিটেলসে যাওয়ার পর এসডি প্লেয়ার, যেটা আমাদের ইমুলেটর, এটা রাইট ক্লিক করে সেট প্রায়োরিটি হাই করে দিবেন। হাই করার পর আপনারা দেখবেন কোনো ল্যাগ নাই, জাস্ট এফপিএস এর দিক দেখেন। এই যে 60 আমি অন করতেছি, কোনো ল্যাগ নাই, অফ করতেছি, কোনো ল্যাগ নাই, দেখেন কোনো ল্যাগ নাই। যে কোনো আমি ওমানে ক্লিক দিতেছি, কিন্তু দেখেন কোনো ল্যাগ নাই, দেখছেন। কিন্তু ওই জায়গায় আমাদের ওই জায়গায় কিন্তু অন অফ হইতাছে, দেখেন, কিন্তু কোনো প্রকার কোনো ল্যাগ নাই। সো যদি ভালো লাগে এই ভিডিওটা, অবশ্যই আমাদের চ্যানেলটা সাবস্ক্রাইব করে দেবেন। দেখছেন কতবার স্টার্ট হয়েছে, কিন্তু কোনো প্রকার কোনো ল্যাগ দেয় নাই। তো আমাদের এই ল্যাগ ফিক্সটা কিন্তু আপনাদের কি বলেন, নর্মাল মেমোরিতেও হবে প্লাস ফাস্ট মেমোরিতেও হবে। আর আরেকটা কথা, এই ল্যাগ ফিক্স যদি হাই প্রায়োরিটি করেন, তাহলে কিন্তু সিপিওর উপরে একটু একটু প্রেশার পড়বে, সিপিওর উপরে। মেমোরি চেমোরি আর কোনো কিছুর উপরে প্রেশার পড়বে না, জাস্ট সিপিওর উপরে, কিন্তু কয়েক সেকেন্ডের জন্য প্রেশার পড়বে। আবার মনে করেন না যে কোনো প্রবলেম হবে আপনাদের সিপিওর, কোনো প্রকার কোনো ঝামেলা হবে না। তো আজকের ভিডিওটা এই পর্যন্তই। সবাই ভালো থাকবেন, সুস্থ থাকবেন, আল্লাহ হাফেজ, টেক কেয়ার, বাই বাই। আর কালকে আমরা আমরা কি বলে দাঁড়ান, কালকে অটো আপডেট সিস্টেমটা নিয়ে আসবো, অবশ্যই। আর আপনারা আমাদের ইউটিউব চ্যানেলে অবশ্যই চোখ রাখবেন সব সময়, কারণ নিত্য নতুন সব কিছু নিয়ে আসবো। প্যানেল প্যানেল নিয়ে সব কিছু এ টু জেড সব কিছু আসবে। ও আজকের ভিডিওটা এই পর্যন্তই। সবাই ভালো থাকবেন, সুস্থ থাকবেন, আল্লাহ হাফেজ, টেক কেয়ার, বাই বাই।
கரெக்டா ரைட்டா கொடுக்கணும், பி ரைட்டா கொடுக்கணும்.
அறிமுகம் பி ரைட் சன்ஃப்ளவர் ஆயில், இந்தியாவின் நம்பர் 1 சன்ஃப்ளவர் ஆயில் நிறுவனத்தின் தயாரிப்பு. எந்த டேஸ்டும் இனி ராங்கா போகாது. ரைட்டான டேஸ்ட், ரைட்டான லைஃப்.
ஹலோ கைஸ், நான் உங்க ஹரிஸ்கர் பேசுகிறேன். இன்னைக்கு நம்ம என்ன பார்க்க போறோம்னா, சும்மா வந்து ரொம்ப நாளுக்கு அப்புறம் பார்த்தீங்கன்னா சரி ஒரு கேம் பிளே அப்படியே லைட்டாக பண்ணி போடலாமே. கேம் பிளேலாம் அந்த அளவுக்குலாம் இருக்காது கைஸ், சும்மா மொக்கையாக தான் இருக்கும். ஸோ ஒரு ரவுண்ட் எடுக்கிறதே எனக்கு பெருசு. ஏன்னா பார்த்தீங்கன்னா ரொம்ப நாளுக்கு அப்புறம் வந்து பிசியில் செட்டிங்ஸ் வச்சு என்ன செட்டிங்ஸ் வச்சுருக்கேன் எனக்கே தெரியல. ரொம்ப ஃபாஸ்ட்டாக இருக்கிற மாதிரியே ஒரு ஃபீல் ஆகுது. அதனாலே பார்த்தீங்கன்னா புல்லட் அக்யூரேசிலாம் மிஸ் ஆகுது. சரி, இந்த புது ஒரு கன்று வேற விட்டுருக்காங்க. சரி, இது நம்ம டெசர்டிக்கல் மாதிரி டம்மு டும்முன்னு பறக்கோட்டு போகலான்னு பார்த்தா படவே மாட்டேங்குது. சரி, இதை வச்சு நம்ம ஒரு கேம் பிளே சும்மா லைட்டாக நம்ம பசங்க ரொம்ப நாளாச்சு. நிறைய பேர் லைவ்லையும் பார்க்குறேன், நிறைய பேர் ஹரிஸ்கர் எங்கன்னு கேட்டுக்கிட்டே இருக்கோம். ஸோ அதுலேயும் பார்த்தீங்கன்னா ஒரு வருஷத்துக்கு ஏதாச்சும் இந்த மாதிரி ஒரு கேம் பிளே அப்பப்போ வந்து போடுறதுக்கு பார்த்தீங்கன்னா வரேன். சும்மா அப்பப்போ ஜாலியாக பார்த்தீங்கன்னா போடுறேன். ஸோ அதுக்கு முன்னாடி பார்த்தீங்கன்னா எத்தனையோ பேத்துக்கு பார்த்தீங்கன்னா இந்த ஐடி ப்ரொமோஷன்லாம் பண்ணி தேவையில்லாத 7.5 அந்த மாதிரிலாம் இருக்குது. ஸோ அதனால பார்த்தீங்கன்னா நம்ம ஆர்பிஎஸ்ஸே பார்த்தீங்கன்னா ஓப்பன் பண்ணிட்டாங்க. ஸோ எந்த ஒரு ப்ராப்ளமும் இல்லாமல் பார்த்தீங்கன்னா சூப்பராக பார்த்தீங்கன்னா வேறு லெவலில் பண்ணிக்கிட்டு இருக்காங்க. ஸோ அந்த குரூப்பில் பார்த்தீங்கன்னா நானும் ஜாயின் பண்ணியிருப்பேன். ஏதாச்சும் ஒரு தப்பு நடந்தால் நான் கேட்கறதுக்கு மட்டும் தான் நான் உள்ளே இருப்பேன், தவிர என்னை அட்மினாக போட மாட்டாங்க. ஸோ அட்மினுக்கு மறக்காமல் கான்டாக்ட் பண்ணுங்கள். கீழே 2 குரூப்போட லிங்க் கொடுத்துருக்கேன். இன்னும் பார்த்தீங்கன்னா 1500 ஸ்பேஸ் கிட்ட இருக்குது. அசால்ட்டாக பார்த்தீங்கன்னா ஜாயின் பண்ணிடுவேன், அது ஒன்றும் பிரச்சனை இல்லை. ஆனால் ஐடி வந்து இது வரைக்கும் யாராச்சும் ஏமாந்துருப்பாங்க. கண்டிப்பாக வந்து நிறைய பேர் வந்து இப்போலாம் ஸ்கேம் ஆகிறதா, ஸ்கேம் பண்ணுறதே ஒரு பொழப்பா ஒரு டீம் பார்த்தீங்கன்னா சுற்றிட்டு இருக்கு. ஸோ அந்த மாதிரிலாம் ஆகாமல் இருக்கிறதுக்கு தான் பார்த்தீங்கன்னா இவங்களே பார்த்தீங்கன்னா ஓப்பன் பண்ணிட்டாங்க. ஸோ இனிமேல் எந்த ஒரு ப்ராப்ளமும் ஆகாது. இந்த குரூப்பில் மறக்காமல் ஜாயின் பண்ணுங்க. உங்களுக்கு வாங்குறது யாருக்காச்சும் வேணும்னா கூட இதில் ஜாயின் பண்ண சொல்லுங்கள், இல்லை கொடுக்கணும்னா கூட இதில் வந்து கொடுங்க. ஒன்றும் பிரச்சனை இல்லை, எந்த ஒரு ப்ராப்ளமும் வராமல் நான் பார்த்துக்கிறேன். ஸோ நம்ம ஜாக்ஸ்பர் ப்ரோவும் இருப்பார், அதில் பார்த்தீங்கன்னா ரிவால்ஸ் இருப்பாங்க. எல்லாருமே நம்மளுக்கு தெரிஞ்ச எல்லா சர்க்கிளும் இருப்பாங்க. ஏன்னா வந்து நம்ம ஒன்று ட்ரஸ்டடாக சொல்கிறோம்னா அது எவ்வளோ ட்ரஸ்டட்னு உங்களுக்கே தெரியும். இந்த உங்களுக்கு நம்ம மேலே ஒரு நம்பிக்கை இருக்கும். கண்டிப்பாக பார்த்தீங்கன்னா ஜாயின் பண்ணுவேன்னு நினைக்கிறேன். ஓகே, நம்ம வந்து இந்த கேம் பிளேக்குள்ளே பார்த்தீங்கன்னா போயிடலாம். இது ஒரு கேவலமான ஒரு கேம் பிளே தான் இருந்தாலும் பார்த்தீங்கன்னா இது எப்படி வந்து அட்லீஸ்ட் ஒரு ரவுண்டாச்சும் அடிப்பேனான்னு பார்க்கலாம். ஓகேவா? ஓகே, இந்த இடத்துல பார்த்தீங்கன்னா சரி இந்த ஒரு புதுக்குன்னு விட்டுருக்காங்க அப்டேட்டில் நானும் சொல்லிட்டு வந்துட்டேன். சரி மேட்சே ஏதோ ஒரு ஏன்னா தானே, அதாவது என்னோட சென்சிட்டிவிட்டி ரொம்ப லோவாக, அதாவது மோஸ்ட்டாக நான் தான் இருக்கிறதே லோவாக வச்சு ஆடுவேன். இருக்கிறதுலே திருப்பவே முடியாது. மவுஸை லெஃப்ட் ரைட்னு அடித்தாதான் அந்த மாதிரி தான் திருப்ப முடியும். அந்த மாதிரி செட்டிங்ஸ்லாம் வந்து எதுக்கு யூஸ் ஆகுதுன்னா டெசர்ட் ஈகிள், ஷார்ட் கன்னு எல்லாத்துக்கும் ஒன் டேப் யூஸ் ஆகுது. எல்லா கன்லையுமே அடிக்கலாம். ஆனால் இந்த ஒரு கண்ணில் மட்டும் அடிக்கவே முடியல. என்னடா இது லோ சென்சிட்டிவிட்டி வச்சா அடிக்க முடியலன்னு பார்த்தா இது என்ன இலவுனே தெரியல, கொஞ்சம் டிஃப்ரெண்ட்டாக இருக்குது. ஆனால் வந்து குதிச்சுட்டு அடிக்கும் போது சூப்பராக படுது. இப்போ வந்து நான் 800 வச்சுருக்கேன். 800 வைக்கும் போது கொஞ்சம் ஃபாஸ்ட் சென்சிட்டிவிட்டியாக இருக்கும். ஆனால் இதே சென்சிட்டிவிட்டி வச்சு எந்த ஒரு டெசர்ட்டிகள் ஆட முடியாது, ஷார்ட் கல் ஆட முடியாது, எதுலையுமே ஆட முடியாது. ஆனால் இந்த கல்லில் மட்டும் ஆட முடியுது. இது கொஞ்சம் வித்தியாசமாக இருக்குது. எப்படின்னா பாடியில் வச்சு அப்படி குதிச்சுக்கிட்டு தவிக்கிட்டு ஒரு ட்ராக் பண்ணினா அசால்ட்டாக படுது. அந்த மாதிரி மட்டும் தான் இது பண்ணுது. ஆனால் எல்லா டைமும் பார்த்தீங்கன்னா சென்சிட்டிவிட்டி மாறி அது வேறு குத்து வாங்கிட்டு இருந்தேன். ஏன்னா இது ஒரு ஃபஸ்ட் டைம்னால மேட்ச் பார்த்தீங்கன்னா கேவலமாக இருக்கலாம், ஒரு ஷார்ட்டும் பார்த்தீங்கன்னா கேவலமாக இருக்கலாம். இதுக்கப்புறம் வர மேட்ச் ஃபுல்லாக பார்த்தீங்கன்னா சூப்பராக போடுறேன். ஓகேவா? அதனால பார்த்தீங்கன்னா ஒரு மாதத்துக்கு ஒரு 4 வீடியோ, இதுக்கு முன்னாடி எப்படி தானே போட்டுக்கிட்டு இருந்தேன் அது மாதிரி பார்த்தீங்கன்னா ஒரு 3 ஷார்ட்ஸ் ஒரு வீடியோ அந்த மாதிரி ஜாலியாக போடுறேன், இல்லை 4 ஷார்ட்ஸ் போடுறேன். ஷார்ட்ஸ் ஃபுல்லாக பார்த்து என்ஜாய் பண்ணுங்க. கொஞ்சம் டிஃப்ரெண்ட்டாக இருக்கும். எப்படின்னா வந்து நம்ம கண்டென்ட் எப்படி வந்து நம்ம டிஃப்ரெண்ட்டாக ஒரு கண்டென்ட் போடுவோம். அதுக்குன்னே பார்த்தீங்கன்னா நிறைய பேர் பார்க்குறதுக்கு இருக்குயா. ஸோ அது மாதிரி ஷார்ட்ஸில் பார்த்தீங்கன்னா டிஃப்ரெண்ட்டாக கண்டிப்பாக பார்த்தீங்கன்னா சூப்பராக போடுறேன். அந்த கேம் பிளேயில் பார்த்தீங்கன்னா எந்த ஒரு ஸ்கிரிப்ட் எந்த ஒரு இது இல்லாமல் அப்படியே ஒரு பியூர் கேம் பிளேயாக இருக்கும். அடி வாங்குறோமோ கொடுக்குறோமோ அது சூப்பராக பார்த்தீங்கன்னா இருக்கும் ஷார்ட்ஸில். ஓகே, இந்த ரவுண்டு பார்த்தீங்கன்னா அழகாக பார்த்தீங்கன்னா ஒரு 3 பேர்த்த அப்படி குதிச்சுக்கிட்டே அடிச்சாச்சு. ஓகே, 4வது ஒருத்தவரை குதிச்சுக்கிட்டு வாங்கினா பரவாயில்ல. குதிச்சுக்கிட்டு அடிக்கும்போது சூப்பராக இதில் வந்து படுதுங்க, நல்லா இருக்கு. இந்த கன்று பார்த்தீங்கன்னா எல்லாத்துக்கும் யூஸ் ஆகாமலே தெரியல. ஆனால் வந்து டோர்னமெண்ட் பிளேயர்லாம் டம்முன்னு அடிச்சுட்டு போகிறாங்க. அவங்க என்ன பண்ணுறாங்கன்னா அசால்ட்டாக டப்பு நிற்கிறாங்க, பாடியில் அடிச்சுட்டு ஓடுறாங்க. திரும்பி பார்த்தா டப்புன்னு இங்கிட்டு ஒரு அடி அடிச்சுட்டு போகிறாங்க. அதாவது பாடியில் பார்த்தீங்கன்னா அக்யூரேசி செம்மையாக பிடிக்குது. டப்புன்னு இப்படி சொல்லிட்டு விட்டோம்னா நம்ம பாடியில் வந்து அடிக்குது. அதுக்கப்புறம் ஏதோ 25 ஏதோ எக்ஸ்ட்ரா டேமேஜ்லாம் போகுது. இது என்ன மாதிரி இதுன்னே தெரியல. ஏன்னா ஃபஸ்ட் டைம் வந்து கேமுக்குள்ள ரொம்ப நாளுக்கு அப்புறம் வந்திருக்கல, அதனால பார்த்தீங்கன்னா லைட்டாக பார்த்தீங்கன்னா ஸ்லிப் ஆகுது. ஓகே, இந்த இடத்துல பார்த்தீங்கன்னா நேருக்கு நேராக பார்த்தீங்கன்னா ஒருத்தர் வந்தான்.
We are about to reach our destination. We have covered 280 kilometers in just 4 hours.
Bro, all the way. You must be tired, no?
No, Dadu. We took him in business class.
Enjoy best-in-class features with the
என்னடா பண்ணிட்டு இருக்க? ஓ ஹெட்ஷாட்.
வணக்கம் மக்களே, நீங்கள் பாரு கேட்குறது மொக்க கமிட்டி நாங்கள் ஹோஸ்ட். ஃபைனலி சூப்பர்மேன் படத்துக்கான ஃபர்ஸ்ட் லுக் ட்ரெய்லர் ரிலீஸ் ஆயிடுச்சு. அண்ட் இந்த ட்ரெய்லர் பார்க்கும்போது வணக்கம் மக்களே, நீங்கள் பாரு
Need you to open this. Fix things. Just push down.
Oh,
Are you okay?
need some help?
You just sit down, all right?
I guess your friend doesn't know his own story.
Oh no.
Here, try this one.
Clark, are you okay?
Wait a minute, Lacey.
Come early. The view is so romantic in my balcony.
No pain, no gain.
Wait a minute, Lacey.
Come early. The view is so romantic in my balcony. See ya.
No pain, no gain.
Just push down.
Oh,
Are you okay?
need some help?
You just sit down, all right?
I guess your friend doesn't know his own strength.
Will read. When we have studied acid property, okay, this I stands for this isolation, right? Okay, and it means that how two transactions are isolated to each other. Okay, so the idea is to have transactions isolated to each other, right? And for that we have various isolation level defined in SQL. Okay, and related to each isolation level we also have some violations, like which isolation level is strict and which one has some violations allowed. Okay, so let's learn it. So before we list isolation level and violations allowed, let's understand what are violations. Okay, so what are basically violations? First one which we will be considering here is dirty read. Now second one is non-repeatable read, and the third one is phantom. Okay, so we have understood all of this in previous chapter, but let's quickly revise it. What is dirty read? So if an item is read before it has been committed, so let's say a transaction T1 writes an item A, okay, and transaction T2 reads it quickly after this write, okay. So in that case, this item is not yet committed and transaction T2 reads it, okay. So if this transaction fails, this data which has been read completely becomes irrelevant, okay. So it means that this is a dirty read. Okay, whenever you are reading something which is not committed, then it is dirty read. Now let's focus what is non-repeatable read. So let's say I have this table. Okay, and in table we have data item. This is data item A. Okay, now let's say this transaction T1 reads the value of this. Okay, read A. Okay, and it gets that this is 10. Right, now another transaction T2 modifies this data item, and it modifies it as writes A as, let's say, 20. Okay, so now this becomes 20. Now when this transaction T1 this again reads the item, okay, then initially it was 10, but now it finds it as 20, right? 20. So you can see that between, like, this is reading the data item A and it is getting 20. So you can find that between these two reads by transaction T1 and the transaction T2 modified the data, and when the second transaction, I mean the transaction T1 is reading the data again, then it finds that the value has been changed. Okay, so in that manner, this repeated read is causing a problem, right? We cannot repeat the read, right, due to this intervention of transaction T2. Okay, so this is the problem, and this is called non-repeatable read. Another one is phantom phenomena intervention, and it is as empty data. Now let's say this transaction T1 reads the value of this. Okay, read A. Okay, and it gets that this is 10. Right, now another transaction T2 modifies this data item, and it modifies the transaction T1, and the transaction T2 modified the data, and when the second transaction, I mean the transaction T1 is reading the data again, then it finds that the value has been changed. Okay, so in that manner, this repeated read is causing a problem, right? We cannot repeat the read, right, due to this intervention of transaction T2. Okay, so this is the problem, and this is called non-repeatable read. Another one is phantom phenomena. Phantom phenomena is that, let's say, in a database table, now you have various rows, right? Various rows. A transaction T1 performs a query. Let's say this is Q1. Okay, performs a query, and then he finds two rows are relevant over certain condition. Let's say I'll write C. Okay, so this transaction T1 performs a query over condition C and retrieves two rows, these two rows, right? Now, over certain condition. Phantom phenomena is that, let's say, in a database table, like this is reading the data item A. When the second transaction, I mean the is a transaction T1 performs a query. Let's say this is Q1. Okay, performs a query, and then he finds two rows are relevant over certain condition. Let's say I'll write C. Okay, so this transaction T1 performs a query over condition C and retrieves two rows, these two rows, right? Now a transaction T2 performs a update query. Let's say this is, I'll write as QU over the same condition C. Okay, then what will happen? He inserts another row in between. Okay, another row is inserted by this transaction, and now if the same query is again performed, then another new row is found. So what I'm saying is, initially transaction T1 performs a query over condition C on this table. Okay, and if this transaction finds two rows relevant and it is retrieved. Okay, two rows are returned for this query. Now transaction T2 in between performs update query and inserts another row. Okay, over the same C condition. Okay, now if this query is run again, what will happen? This will retrieve another row. This extra row will be retrieved, right? So this extra row appears query action, finds two rows relevant and it is retrieved. Okay, two rows are returned for this query. Now transaction T2 in between performs update query and inserts another row. Okay, over C on this table. Okay, and if this transaction finds two rows relevant and it is retrieved. Okay, two rows are returned for this query. Now transaction T2 in between performs update query and inserts another row. Okay, over the same C condition. Okay, now if this query is run again, what will happen? This will retrieve another row. This extra row will be retrieved, right? Transaction this transaction finds two rows relevant and it is again performed. Then row update query, let's say relevant over certain condition. Let's say I'll write C. Okay, so this transaction T1 performs a query over condition C and retrieves two rows, these two rows, right? Now a transaction T2 performs a update query. Let's say this is, I'll write as QU over the same condition C. Okay, then what will happen? He inserts another row in between. Okay, another row is inserted by this transaction. And now, if the same query is again performed, then another new row is found. So what I'm saying is, initially transaction T1 performs a query over condition C on this table. Okay, and if this query, this transaction finds 2 rows relevant and it is retrieved. Okay, 2 rows are returned for this query. Now transaction T2 in between performs update query and inserts another row. Okay, over the same C condition. Okay, now if this query is run again, what will happen? This will retrieve another row. This extra row will be retrieved, right? So this extra row appears like a phantom, okay? Because for the same query it was not there, now suddenly it has appeared from nowhere. So for the same query, as it is retrieving another extra row, that is called phantom row, and this phenomena is called phantom phenomena. Okay, so these are the violations. Now let's see for which isolation level which violations are allowed. Now you can see that these are the isolation levels. This is read uncommitted, read committed. It is clear from the name, that is this isolation level allows read uncommitted value, okay, uncommitted data. This doesn't allow uncommitted data, okay, to be read. It allows only committed data to be read. This is repeatable read, okay? So repeatable read, we have just seen that what is a repeatable read, okay? We have seen non-repeatable read, so this is opposite of it. And then this is serializable, okay? So serializable we have studied a lot till now. Now let's see this dirty read, whether it is allowed in read uncommitted or not. So of course, when you read uncommitted data, it is dirty read, right? So it allows dirty read, this isolation level. It also allows non-repeatable read, okay? And it also allows phantom phenomena. When you read committed, of course, dirty read will not be there, and now this read committed isolation level doesn't allow dirty read, but this non-repeatable read may happen in this isolation level, and of course phantom phenomena is also likely to happen. Now next one is repeatable read. So when you have repeatable read, of course this non-repeatable read problem will not be there, and this dirty read will not be there, okay? So only thing remaining is phantom phenomena here. And for serializable, all are taken care, none of the violation is allowed. Okay, so generally that's why if a data item, but the first thing is that you ensure that now scheduler enforces serializable isolation level, okay, so that everything will be correct. So now in next chapter we will learn how we can enforce serial.
That is coming to non-serializable schedule, it always gives inconsistent result. That is, its result is not equivalent to the result of its transactions executed serially. Serializability items, right? It can be given if transaction 1 will not while they satisfy the non-serial schedule, same set of transaction as done. Now, what is serializability actually? So what do we do now to check if it is equivalent to, then we CPU to transaction T2 wait W2 W1 we can have R2.
Hello learners, inconsistent அப்படினா ரீட் பண்ணதுக்கு அப்புறம் நெக்ஸ்ட் நான் சீரியல் ஷெட்யூல் என்ன பார்க்கலாம். நான் சீரியல் ஷெட்யூல்ல மல்டிபிள் டிரான்சாக்ஷன் எக்ஸிக்யூட் கன்கரண்ட்லி, மோர் தென் ஒன் டிரான்சாக்ஷன் ஒரே நேரத்தில் எக்ஸிக்யூட் ஆகும். கன்கரண்ட்லி அப்படின்னா சேம் டைம்ல. ஆபரேஷன் ஆஃப் ஆல் த டிரான்சாக்ஷன் ஆர் இன்டர்லிங்க் ஆர் மிக்ஸ்ட் வித் ஈச் அதர். ஒரு எக்ஸாம்பிள் பார்க்கலாம். T1 T2 2 டிரான்சாக்ஷன் எடுத்துருக்கேன். இதுல பாத்தீங்கன்னா ஃபர்ஸ்ட் நான் A வேல்யூவை T1 ரீட் பண்றேன்.
Hello viewers, in this video we are going to discuss serializability concept. Specifically, we are going to discuss conflict serializability and view serializability techniques. Actually, serializability, it is the process used to find if the given non-serial schedule is a serializable schedule or non-serializable schedule. Usually, we can classify the non-serial schedule into two types. Serializable serializable schedule and non-serializable schedule. Usually, this serializable schedules provides consistent result. That is, its result is equivalent to the result of its transactions executed serially. Okay, whereas coming to non-serializable schedule, it always gives inconsistent result. That is, its result is not equivalent to the result of its transactions executed serially. Hello viewers, in this video we are going to discuss serializability concept. Specifically, we are going to discuss conflict serializability and view serializability techniques. Actually, serializability, it is the to find if the given non-serial schedule is a serializable schedule or non-serializable schedule. Usually we can classify. Actually, serializability, it is the process used to find if the given non-serial schedule is a serializable schedule or non-serializable schedule. Usually we can classify the non-serial schedule into two types: serializable schedule and non-serializable schedule. Usually this serializable schedules provides consistent result. That is, it result is equivalent to the result of its transactions executed serially. Here, coming to non-serializable schedule, it always gives in non-serializable, non-serial schedule since it produces inconsistent result. This type of non-serializable schedule since it produces actions executed serially. So this non-serializable, non-serial schedule since it produces inconsistent result. This type of non-serializable schedule should not be permitted to execute. That's why serializability concept is used to find out whether the given non-serial schedule is serializable or not. We can check the given non-serial schedule as serializable or not by using two serializability techniques. One is conflict, another one is view serializability. Now we are going to discuss about these two serializability techniques with examples. Let's discuss conflict serializability. Conflict serializability, it is one type of serializability technique which is used to check whether a given non-serial schedule is conflict serializable or not. It performs this process by converting the given non-serial schedule into serial schedule by swapping its non-conflicting operations. Let's check what are the conflict operations and non-conflict operations now. Here, if two transactions are performing operations on the different data items, then those operations are known as non-conflict operations. Because the transactions are doing operations are different data items, right? It nowhere violates consistency property. So the operations which are performed on different data items are usually non-conflict operations. If suppose the two transactions are performing operations on the same data item, write operation on data item Q. Okay, here this is non-serial schedule. How come it is known as non-serial schedule? Here, before the completion of T1, T2 is permitted to execute, right? So that is why it is known as non-serial schedule. So according to conflict serializability, to determine whether the given non-serial schedule is conflict serializable or not, we have to swap the non-conflict operation. After swapping, if we are able to make the serial equivalent of this, then it is known as conflict serializable schedule. Okay, so let us try to swap the non-conflict operations in T1 and T2. Here, these two operations are non-conflict. Though these two are T1 and T2 are performing the read operation on same data item A, they read and read never violate the consistency. So it can be swapped. So now after swapping, this read operation comes up and this read operation goes down. So now this is the intermediate result of this non-serial schedule. Then after this, let us try to swap these two. Since T1 and T2 performs read operation on different data items, it is also non-conflict. So it can be swapped successfully. Okay. Then after swapping, we will get this. The result of the schedule, non-serial schedule will be like this. Then to get the serial equivalent of this, one more step is required. That is, it has to come down and it has to go up, right? So either these are conflict or not. Let us check. Here, both T1 and T2 are performing read and write operation on different data items. Okay. So irrespective of any operation, if transactions are performing operations on different data items, obviously they are non-conflict. So these two can be successfully swapped. So after swapping, we will get the serial schedule like this. Here, this is serial schedule. How come? Because all operations in T1 are executed first, and after the completion of it, operations in T1 is permitted to execute. That's why it is a serial schedule. So this is the serial equivalent of this non-serial schedule. Okay. Since this non-serial schedule S1 How come? Because all operations in T1 are executed first, and after the completion of it, operations in T1 is permitted to execute. Since this non-serial is permitted to execute. Okay, students, I hope you understood what is conflict serializability. And one more point, non-serial schedule is known as conflict equivalent of serial schedule. If it can be successfully converted to serial serial schedule by stopping its non-conflict operation. Okay, so in such case we can say the given non-serial schedule is the conflict equivalent of its serial schedule. Okay, let us now discuss view serializability with an example. View serializability, it is also one type of serializability technique which is used to find out whether the given schedule is view serializable or not. If schedule is view equivalent to its serial schedule, then it is view serializable. Okay, let us now check what is view equivalent, what are the conditions to be satisfied to determine whether the given schedule is view equivalent of its serial schedule or not. Let us now discuss. Two schedules, S1 and S2, the given schedule is view equivalent of its serial schedule or not. Let us now discuss. The schedule is view serializable or not. Serial schedule, we can say with an example. If the schedule is view equivalent to its serial schedule, then it is view serializable. Okay, let us now check what is view equivalent, what are the conditions to be satisfied to determine whether the given schedule is view equivalent of its serial schedule or not. Let us now discuss. Conditions to be satisfied to determine whether the given schedule is view equivalent of its serial schedule or not. Let us now discuss. Two schedules. Whether the given schedule is view equivalent of its serial schedule or not. Let us now discuss. Two schedules, S1 and S2. Whereas S1 is non-serial schedule and S2 is serial schedule. Okay, two schedules, non-serial and serial schedules are said to be view equivalent if they satisfy the following conditions. That is, if in both schedules S1 and S2, the transactions that perform initial read, final write, and update read operations on each data item are same. Okay, so you can understand this very clearly when we discuss with an example. Okay, here very clearly when we discuss with an example. Okay, here this is what the given non-serial schedule. Now we are going to check whether the given non-serial schedule is view serializable or not. So to determine either it is view serializable or not, three conditions need to be satisfied. Okay, what are the three conditions? Initial read, final write, and the update read on each data item must be done in both the schedules by same set of transactions. Okay, so that's what we are going to check now. Here, what are the two data items are here? A and B, right? So these two are the data items are used in this schedule. Okay, here A, here A, here B, 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 B. So totally there are two data items are used in this schedule. Okay, let us check which transaction performs initial read, final write, and update read on these data items. Here on A, who performs initial read? T1, right? Initially, who performs the read operation on A? T1. Then who performs the update read on A? Update read, it means after the write operation, who performs the read? Okay, so after the write operation on A by T1, T2 reads its value. So update read operation is performed by T2. Then who performs the final write on A? There are two write operations, but final write is performed by T2. So accordingly, if we check on data item B, initial read is done by T1, update read is done by T2, and final write on B is done by T2. So now we have to check either the same set of transactions performs these operations in serial schedule also on each data items. initial read T1, right? Initially, who performs the read operation on A? T1. Then who performs the update read on A? Update read, it means after the write operation, who performs the read? Okay, so after the write operation on A by T1, T2 reads its line. So update read operation is performed by T2. Then who performs the final write on A? There are two write operations, but final write is performed by T2. So accordingly, if we check on data item B, initial read is done by T1, update read is done by T2, and final write on B is done by T2. So now we have to check either the same set of transactions performs these operations in serial schedule also on each data items. Okay, this is the serial equivalent of this non-serial schedule, right? So how we got this? Simply we arranged all the operations in T1 first, and followed by that all the operations in T2 must be written subsequently. Okay, but there should not be any overlap between the operations of T1 and T2. Then only it is known as serial schedule, right? Okay, let us now check initial read, update read, final write on A and B. Okay, here who performs the initial read on A? T1. Okay, update read on A is performed by T2, right? So after the write on A, T2 performs the read operation. Then who performs the final write on A? So there are two write operations on A, so final write is performed by T2. So very similarly, even on B also, T1 performs the initial read, T2 performs the update read, T2 performs the final write. So here we got this set of operations. Okay, here let us now check either the same set of operations performs initial read, update read, final write on A in both the cases. Yes, we check. You can notice that T1, T2, T2, T1, T2, T2. So same transaction performs all the three operations on A, and this is applicable on B also. Okay, since on each data item, same set of transaction performs all the three operations, we can say that the given non-serial schedule is view serializable. That is, the given non-serial schedule is the view equivalent of its serial schedule. Let us take one more example to discuss view serializability. This is for the given non-serial schedule. Okay, and in this non-serial schedule, there are two transactions are there, and both the transactions are performing operations on single data item. operations in T1 followed by the operations in T2, and there should not be any overlap between the operations in T1 and T2. So if there is no overlap, we have to on view serial. Let's move on. Operations performed in. Thanks for watching.
read. Okay.
What are transaction isolation levels? As the name itself says, when we have multiple transactions within an application which run against the database, we need to isolate the underlying data for each transaction. That is what we control using the different transaction isolation levels. Updating the price information from the database, the transaction B comes in and up. This is very similar to anomalies can be avoided. Transaction read committed, repeatable read, and serializable. Transaction read committed, if we use this transaction isolation level, the transaction can read uncommitted data. This is where dirty reads will happen if we use this read uncommitted level. And also the less performing transactions. These anomalies can be avoided by using transaction isolation levels. In the Java EE world, there are 4 transaction isolation levels: transaction read uncommitted, transaction read committed, repeatable read, and serializable. Transaction read committed, if we use this transaction isolation level, the transaction can read uncommitted data. This is where dirty reads will happen if we use this read uncommitted level. Dirty reads, non-repeatable reads, and phantom reads can occur. All of the anomalies will occur if we use the first level. The second one, transaction read committed, ensures that our transactions read only the committed data. So if we use this level, then we will avoid the dirty reads. Still, we'll have the non-repeatable reads problem. Dirty reads are prevented, non-repeatable reads and phantom reads can still
हाय, टुडे वी आर गोइंग टू लर्न सॉर्टिंग इन क्वेरी। अगर आपका कोई डेटाबेस है और आप चाहते हैं कि वो सॉर्टेड ऑर्डर में डिस्प्ले हो, तो उस समय आपको सॉर्टिंग रिक्वायर्ड होता है। तो सॉर्टिंग रिक्वायर्ड व्हेन वी यूज ऑर्डर बाय इन एसक्यूएल और वी वांट टू रिमूव duplicates in the records, as well as if you want to use join, union or intersection operation, and if you have used sorting before these operation, the operation will be more efficient. तो सॉर्टिंग अब आप परफॉर्म कैसे करेंगे? एक तो ये मेथड है कि जब आपका इंडेक्सिंग है तो इंडेक्सिंग आपको सॉर्ट की प्रोवाइड करे, और तो कितनी आपके रन फ्लोर वैल्यू ऑफ बी कितनी बार आप ले आए, ठीक है, वो आपके कॉस्ट में इंक्लूड होगा। फिर मर्जिंग फीस भी कॉस्ट में इंक्लूड होगा। इस तरीके
Hello everyone, today we are going to see external sort merge accesses while reading the record, which is very sorting. We can merging n read m minus, again these two will be compared and then we will be getting the Hello guys, welcome back to K Tutorials. Today we are going to learn about dividing the Hi students, welcome back. Coming to the next topic, that is the states of transactions. So whatever the transaction you are doing, so for each transaction there are different states. So based on the state, we can say is the transaction is successful or not. Okay. So the different transaction states are active. So one is active state. Okay. Next is partially committed state. Okay. And there is failed state, whether your transaction may be in failed state, committed state, aborted state, and terminated state. So these are the altogether 6 states are there. So whatever the transaction you can take, that transaction may be in active state or partially committed, failed failed state, committed state, aborted state, or terminated state. Okay, so here the read and write operations will be done while your state is going from active to partially committed state. So if your state is partially committed, then you have to make it as a, if everything is fine in your transaction, you have to make it as a permanent state by sending it to the committed. So after committed, the program will be terminated. Suppose the active any failures is occur in your transaction while you're doing the transactions, if failure is occur, it enters to the failed state. Otherwise, if you're doing some work after read write operations also, if some means after the partially committed state, terminated state. Okay, so here the read and write operations will be done while your state is going from active to partially committed state. So if your state is partially committed, then you have to make it as a, if everything is fine in your transaction, you have to make it as a permanent state by sending it to the committed. So after committed, the program will be terminated. Suppose the active any failures is occur in your transaction while you're doing the transactions, if failure is occur, it enters to the failed state. Otherwise, if you're doing some work after read write operations also, if some means after the partially committed state, if failures occur, then it enters into the failed state. From failed to, it rollbacks to the aborted state and then terminate the program. Okay, so without executing. So here the transaction without executing means the values that in the database will not be changed. If this transaction entered into the failed, aborted, and terminated. Okay, and if you take this line from active to partially committed to committed, and terminated. So in this cycle, the transaction will make it as a successful and it should be consistent. Here it is consistent database will be there, and here it will be aborted. Aborted also it should be a consistent. You are making the main of the transaction using the transaction on the databases means you have to make the you have to see that the database should be always in consistent state. So while you're doing the transactions on the database, you make sure that whatever the transactions you are doing, that transactions should follow the ACID properties, and these ACID properties will make sure that it always keep your database in consistent state. Okay, so here suppose if you're doing some your transaction is an active, so whenever it is active, if it is doing the series of operations, so the transaction is doing series of operations. Okay, so after doing the series of operations, it is reading and writing the operations and making them as a partially committed. So partially committed means it is not saying that whatever the data that you read and write is permanently stored in a database. So whatever the transactions you are doing, okay, first those transactions will be stored in a buffer. So you call it as a local memory. So first the transactions, whatever the work you are working on the transactions, so that will be stored in buffer, that is a local memory. So this stage you call it as a partially committed. You are not storing completely in database. Okay, so here the buffer is all the read and write operations will be stored in the buffer local memory. So it checks after the completion of the operation if everything is satisfying the ACID property. Okay, if all the transactions is satisfying the ACID properties, then it makes that statement to the permanent state with the help of commit. So whenever you use the commit statement, this values, whatever that is there in the local buffer, whatever the data that is stored temporarily in the local buffer, that will be moved to the main database. Okay, so so after the committed, that values will be stored in the database. So after that the program will be terminated. Okay, so first the transaction will start, it goes a series of operation, and after the read write operations it went into the partially committed state. That partially committed state will all the values will store in the local buffer local memory. Okay, so I mean it doesn't disturb the main database. So after the committed operation, then only those values will be stored in the database. Okay, so before partial committed also the program may get the fail. Suppose if it is an active state, if it is doing the series operation, suddenly system crash is occurred. Okay, suppose a system crash or some power failure occurs, it enters into the fail state. Okay, suppose if it is in partially committed, means all the values are already stored in the buffer local memory. Suddenly power fails. Okay, what it does, it enters into the fail state. So after entering the fail state, it rollbacks. What this rollback will do? This rollback will clear the buffer. It clears the buffer local memory, whatever the values that already stored, that read write operations regarding to the transaction that already stored in local buffer. So whenever it is failed, rollback means it clears whatever the data that is present in the buffer. Okay, and it is aborted. Aborted means it keeps unchanged. So whatever the values that you make on the transactions, that keeps unchanged, and it should be terminated. And keep the database in consistent state without changing the values. And it keeps the database in consistent state without changing the values. So these are the different transaction states when whatever the transaction you are doing, that may be in active state, or it may be partial state, or it may be failed state, committed, aborted. So after the completion of everything, the program will be terminated, and you have to make sure after terminating the database should be in consistent state. Okay, thank you.
Hi students, coming to our next topic, that is ACID properties. So in the previous video we had seen that what is a transaction management and what are the transaction means. So let us see here the ACID properties. So first thing is, in order to maintain database, in order to maintain consistency in database. So in order to maintain consistency in database before or after transaction, certain properties are followed by the transaction. So if you want to maintain the database in consistency state, means to in correct state, so before or after transactions, these transactions has to follow some certain properties. So those properties you call it as ACID properties. Okay, so the main use of this ACID property is to ensure, in order to ensure accuracy, completeness, and data integrity, we will use this ACID property. Okay, so here A means atomicity, C means consistency, I is isolation, and D means durability. So these are all the different properties that are used while you're doing the transactions. So if the transaction satisfies all these properties, then you can say that the database, whatever the database you're having, that database is in consistent state. It is following the correct procedure, it is having the accurate correct values. So atomicity, consistency, isolation, and durability. So let us discuss one by one. So first is atomicity. So what is atomicity? So it states that the transaction must be atomic. The first point is the atomicity is nothing but it states that the transaction, whatever you are doing, that must be atomic. Transaction must be atomic. So what it means? Atomic means either all of its operations are executed or none operations. Means all transactions should be completed or none. So nothing has to be done. Means your database is unchanged. So atomicity means it must be atomic. Atomic means it has to do all the operations or it doesn't do anything. Okay. So you call this atomicity is also called as all or nothing rule. So we call it as all or nothing rule. Okay. So here if one part of transaction fails, entire transaction is also failed in the database. Means if suppose it's doing some operation, suddenly some failure is occurring in your database. So what it does, it will makes the transactions unchanged. So whatever the before your database is in the consistent state, it will be also in that consistent state itself. Okay, means it's all or nothing rule. It does if all the transaction has to be completed or nothing will be completed. So here it involves two operations. In atomicity, involves two operations: abort or commit. Abort or commit. Abort means changes made to database are not visible. So whenever you are keep the transaction as abort, whenever you say the transaction is abort means the changes whatever made to a database are not visible, means they are not saved. Commit means changes made to database are visible. So means after the completion only we are use the commit statement. Whenever you make the statement transaction as a commit, then whatever the changes that are made in the database are visible to you. Okay. So let us take one example for explaining this atomicity. Example. Right. T1 and T2 are two transactions. Let us take these are two transactions. Okay. So if you want to transfer amount, suppose amount 100 rupees from account A to account B. Okay, so two transactions are there. You want to transfer 100 rupees from account A to account B. So already in account A you are having 500 rupees and in account B you are having 200 rupees. So 500 rupees and 200 rupees are there. So that is the T1 transaction. First what it does, it read A value. So 500 is read first. So after that A minus 100 means the 100 amounts you have to be transferred. So deduct 100 rupees from A account. Then you have to save it. Write A. So T2 transaction. Read B. So whatever the B consisting of 200 rupees. So it reads 2 and the B is equal to B plus 100. Means we are transferring A to B. So A 100 should be minus and B 100 should be added. Right? B. So now value of A is, here it is 400 and here it is A and B is 400 plus 300 is equal to 700. So then we can say that the database in consistent state. So after doing the transactions also the database is maintaining the consistent state. Okay. So this A and B is 400 plus 300 is equal to 700. So then we can say that the database in consistent state. So after doing the transactions also the database is maintaining the consistent state. Okay. So this actually the exact process. Suppose some failure is occurred. So if you are not using the atomicity property one before inconsistent state, A is deducted but it is not. If suddenly the system transaction is completed, if you before in the middle of the transactions the system doesn't make what it is, the amount in A is deducted but is not added in B. So the result will be in inconsistent state. So the result is it is in inconsistent state. after the completion of T1 before T2, okay, if suddenly the transaction system fails, the amount in account A is deducted, but it is not added in the B. So it will cause the inconsistent state. Okay, so to overcome this problem, we are using the atomicity. So what this atomicity will do? Okay, so if suddenly the system fails, it keeps whatever the changes that are made in the system will be unchanged. That means aborted. The transaction is aborted. So changes made to database are not visible until the transaction is completed. Okay, so after transaction is completed, if you use the commit statement, then only the changes made to the system are visible. So this atomicity will help the transaction to maintain the database in a consistent state. So whenever the system fails before in the middle of the transactions, the system doesn't make those changes as a permanent until you commit the system. Okay, so that you call it as atomicity. Hi students, welcome back. So in the previous video, we are discussing the acid properties. So acid properties. So in that we had seen what is atomicity. So now let us see what is consistency. What is it? The consist. So in that video, we had seen that atomicity means it is only must be atomic. Means it has to do all the operations or nothing will do. Now coming to the consistency. So consistency is nothing but correctness. So you call it as a correctness. That means that the integrity constraint must be maintained so that database is in always consistent state before or after transaction. Okay, so it is saying that the consistency, you call it as a correctness, that the integrity constraint must be maintained so that the database, whatever you're using, that should be always in consistent state before or after transactions. So you have to make sure after the transaction also they should be in consistent state. So let us take the example. So in the previous example, we have taken two accounts A and B. A is having the amount as 500 and B in account there is a 200 amount. Okay, suppose sum of A comma B is equal to sum of A comma B, means before transaction should always equal to after transaction. Then you can say that your database is in consistency state. So before transaction, A is 500 and B is 200. So after transaction, A is 400, 100 is deducted and is transferred to B, 300. So 700 is equal to 700. Then you can say that the database is in consistent state. Okay, so this is for the consistency. So this is the second property. Now coming to the third property, isolation. So what do you call this isolation? It's nothing but it indicates that the actions performed by a transaction will be isolated or hidden from outside the transaction until it terminates. So simply isolation is transactions should be in isolation. It cannot be visible to other transactions until it completed. Okay, until one transaction is completed, you cannot show that transaction to another transaction. It should be in isolation state. Okay, so let us take one example for explaining the isolation. Suppose T1 is one transaction, T2 is another transaction. Okay, so let us take for all the same example, the bank example. So first read A value. So A value contains 500 before. So now A minus 100. So we deducted 100 rupees from account A. Then you write A. Okay, so next write B, read B, B plus 100 and write B. So this is another transaction. So means this is completely one transaction. It says that you are transferring the amount, okay, 100 rupees from here to here. Okay, so after transaction, this value will becomes the 200 plus 100, 300, and here it is 400. Okay, so then it maintains the database in consistent state. Here isolation means suppose after completion of these, another transaction is started. It's saying read X. So read A. So A value is 400. Okay, and then read B. B value is not 400. Okay, 400 it is written 400. Okay, because it is minus A is 500. 500 minus 100 400. So it is already write the A means it commits the value of A in the account. Okay, the A account is committed. So read X means it only reads the 400, not 500. It doesn't read the before value. After the commit, it reads the committed value. So 400. B value is 200. So A plus B means here 600. Okay, so did you find the difference here? If the transaction is not completing, if the data used during execution of a transaction is not completed, so in between this another transaction is seeing this data, okay, and it is performing the operation, and you will get another value, means the database in inconsistent state. So to avoid this problem, we are using the isolation technique. Okay, so isolation property. So what this isolation will do? The data used during execution. So whatever the data you use during execution of a transaction. So for a complete transaction, you are using one data. Okay, the data used during execution of a transaction cannot be used by second transaction until first one is completed. So until first one is completed, another transaction cannot be used those values. That you call it as isolation. Maintaining, you are hiding the values of one transaction to another transaction so that the database will not come to inconsistent state. To make the database as a consistency, so we are using isolation property. Means here the values in transaction 1 cannot be used by the second transaction until the first transaction completes its operation. Okay, so that is isolation. Now coming to the next property. So what is the next property? That is durability. Durability. So what do you mean by durability? Durability means all updates done by a transaction, all values in transaction 1 must become permanent. Okay, so whatever the updates and updations done by the transaction must become permanent. Means it use the commit statement. Okay, so here the durability is saying that whatever the transactions you are done and if it is updation is done, then it makes the transaction permanent. Okay, permanent means suppose the system fails. Suddenly the system fails. If your database using the durability property, that database will maintain the consistent state. Means whatever the updations it's done in the transactions will not be removed until you change. You have to be noted until you change. Until you change, the values in database will not be until permanent. Done by a transaction must become permanent. Okay, so whatever the updates and updations done by the transaction must become permanent. Means it use the commit statement. Okay, so here the durability is saying that whatever the transactions you are done and if it is updation is done, then it makes the transaction permanent. Okay, permanent means suppose the system fails. Suddenly the system fails. If your database using the durability property, that database will maintain the consistent state. Means whatever the updations it's done in the transactions will not be removed until you change. You have to be noted until you change. Until you change, the values in database will not be erased or removed. Okay, so that you call it as a durability. So these are the different acid properties. So here A you call A is atomicity. So what this atomicity will do? Transactions whatever suddenly the system fails, if your database using the durability property, that database will maintain the consistent state. Means whatever the updations it's done in the transactions will not be removed until you change. You have to be noted until you change. Until you change, the values in database will not be erased or removed. Okay, so that you call it as a durability. So these are the different acid properties. So here A you call A is atomicity. So what this atomicity will do? Transactions will do all or nothing. So atomicity is nothing but it uses a property as all or nothing. So what is C? Okay, what do you mean by C? C is the consistent state. Means only valid data is saved. So that is C, the consistency. Next is I. I is nothing but isolation. So what this isolation will do? Transactions do not affect each other. Will not atomicity, consistency, isolation, and durability. Okay, so one thing here you can note that. So if you Hi students, welcome back. Let us continue with the database management system topics. In the previous video, I explained about the different types of attributes. Now let us see in the type of attributes we have use some is community set. Two entities, that's it. That is one to one. And this you can represent a cardinality limits. And this and here one to one relationship. If you mention the cardinality in this place, means hi students, welcome back. Let us continue with the hi students, welcome back. Let us continue with the database management system topics. In the previous video, I explained about the different types of attributes. Now let us see in the type of attributes we have use some pictorial representation, means the symbols for the attributes: simple, composite, derived, single level, single value, multi-value attributes. Now let us see total how many components will be there and what are those components that are used for ER diagrams, entity relationship diagram components. So actually, the ER diagrams is nothing but it is a pictorial representation. It is a pictorial representation of data. So whatever the data that is there, that can be represented in a pictorial. So in this diagrammaticality, so but it is a pictorial that characterized this. It's a side arrow is this is many to, and this is for total generalization, only generalization, total generalization. And if you mention disjoint here, you call it as a disjoint generalization. And coming to some more ER notations, and these are some alternative ER notations here. Suppose here is an entity set. This entity set is having that
entity relationship diagram. The entity relationship diagram or ER diagram, or in short we can call it as ERP, can express the logical structure of the database graphically. We know that graphical representation, pictorial representation of a system will be more comprehensible and easy to understand. So such graphical or pictorial representation plays a very vital role to represent one database. So here is the definition, which we have discussed already. This ER diagram consists of the following major components. First, entity relationship diagram. The entity relationship diagram or ER diagram, or in short we can call it as ERP, can express the logical structure of the database graphically. We know that graphical representation, pictorial representation of a system will be more comprehensible and easy to understand. So such graphical or pictorial representation plays a very vital role to represent one database. So here is the definition, which we have discussed already. This ER diagram consists of the following major components. First one is the rectangle. Rectangles will be denoting entities. So entities will be enclosed within rectangles. Ellipse will be denoting the attribute. So each and every attribute must be enclosed within ellipse. Diamonds will be denoting the relationship. What is the relationship? What is entity? What is attribute? We have discussed everything in our prior videos. Diamonds will be denoting the relationship. Lines will be denoting the links between, say, attribute and entity and relationship. Links will be denoted by lines. Double ellipse will be denoting the multi-valued attribute. Dash ellipse will be denoting the derived attribute. Double lines will be denoting total participation, that is merging in between the relationship and the entity. And double rectangles will be denoting the weak entity set. So weak entity Each and every attribute must be enclosed within ellipse. So in here, pictorial representation of a system present one database. So here is the definition, which we have discussed already. This ear diagram consists of the following major components. Ellipse will be denoting the attribute. So each rectangles will be denoting entities. So entities will be enclosed within rectangles. Ellipse will be denoting the attribute. So each and every attribute must be enclosed within ellipse. Diamonds will be denoting the relationship. What is the relationship? What is entity? What is attribute? We have discussed everything in our prior videos. Diamonds will be denoting the relationship. Lines will be denoting the links between, say, attribute and entity and relationship. Links will be denoted by lines. Double ellipse will be denoting the multi-valued attribute. Dash ellipse will be denoting the derived attribute. Double lines will be denoting total participation, that is a valued attribute. Dash ellipse will be denoting the derived attribute. Double lines will be denoting total participation, that is a merging in between the relationship and the entity. And double rectangles will be denoting the weak entity set. So weak entity set means that entity set which does not have any primary key but can have partial key. So that entity will be known as the double rectangles, will be denoted by the double rectangles in the entity relationship diagram. I think our conception will get clear if you go through one example. Here you see, this is a very simple example which we discussed in our earlier videos also. So here the student is one entity, here this book is another entity. As a result of that, the student and this book, they have been kept in rectangular boxes. So this is my issue. Issue has been put within a diamond box denoting the relationship. And all these attributes are enclosed within ellipse denoting that they are attributes. This double ellipse will be denoting the mobile number, which is a multi-valued attribute. That's why a student can have multiple mobile numbers, so that's why it is multi-valued attribute and put within double ellipse. This dotted ellipse is denoting the derived attribute, because if you know the date of birth from the system's current date, we can easily calculate the age of a student. So this age value can easily be calculated using some calculations or business rules or something. So those attributes will be known as the derived attributes. This is my prime attribute, so that's why role has been put, because if you know the date of birth from the system's current date, we can easily, and ellipse will be, and all these attributes are enclosed the multi-valued attribute. That's why a student can have multiple mobile numbers, so that's why it is multi-valued attribute and put within double ellipse. This dotted ellipse is denoting the derived attribute, because if you know the date of birth from the system's current date, we can easily calculate the age of a student. This is composed into the simple attributes: first name, middle name, and the last name. Address is also a composite attribute consisting of three simple attributes: city, state, and zip, and another composite attribute, street. The street is having the street number, street name, and apartment number. So because this particular other attribute, we have discussed what is ear diagram and how to draw them. In this session, we are discussing ear diagrams and different symbols used in that. So there are so many symbols are there which can be used in an ear diagram. We shall go one by one through these particular diagrams. See, the first one is the entity set, which will be denoted by one rectangle, and the entity will be written within that particular rectangle. So this is a rectangle, and the entity name will be written within the rectangle. This is a weak entity set. Weak entity set don't have any kind of primary key. It does not have any primary key. It is having a partial key. We shall have a separate video where we shall discuss weak entity set more into details. Relationship set will be denoted by diamond, and the relationship set name will be written inside. Identifying relationship will be denoted by this double diamond, and this identifying relationship name will be written inside. In case of primary key, we know that attribute will be enclosed within ellipse, and in case of primary key, it will be having underline. So a attribute name, and it will be underlined. In case of many-to-many relationship, there will be no arrow across these edges. So in case of many-to-many relationship, there will be no arrow across these edges. In case of one-to-one relationship, there will be arrows on both directions as it has been shown. In case of many-to-one relationship, there will be arrow from many to one. So obviously, in case of one-to-many relationship, this arrow will not be here, but there will be one arrow here. So always remember, from many to one, the arrow will be directed. So we have discussed this one. Next one is the role indicator. The role indicator will be shown in this way. So this is my relationship set, this is my entity set, and the role name will be written across the link or line. Attribute will be denoted in this way. Multi-valued attribute will be denoted by double ellipse. Derived attribute, whose value will be calculated by some calculations, by some business rule, will be enclosed within dashed ellipse. Total participation of entity set in the relationship will be denoted by double lines in between the relationship and the entity. Discriminating attribute of weak entity set, that is a partial key, will be denoted by A with a dashed underline. Many-to-one relationship we have discussed earlier. Cardinality remix will be denoted in this way. Here it has been written as 1.h. That means each and every entity, the respective primary key value, can exist here for minimum one time and for maximum h number of times. So that is our 1.h. This is a case where we will be going for generalization and specialization, and it will be denoted by is A. So there will be one triangle, within that is A will be written. We shall have a separate video on this very particular topic discussion. You can go through that video to have a better conception. So these are the very common symbols which will be used in our ear diagram design. Denoted by is A. In this session, we are
Hi guys, welcome back. In this video, I'm going to discuss with you some properties of B-tree, and after the discussion of these properties, I'm going to take an example and we'll create a B-tree with the help of that example. Okay, so let's see. What is B-tree? It is also known as balanced M-way tree. Here M means order of that tree. See, if it is given that create a B-tree of order 5, then here M is equal to 5. That is M-way tree. That tree would be 5-way tree. If order is given of a tree, then maximum children would be same as the order given M. Minimum children would be M by 2, ceiling. Maximum keys would be M minus 1, and minimum keys would be M by 2, ceiling minus 1. Right? So here I'm going to take this example. Order is 4. So here maximum children can be 4. Right? Minimum children can be 2. Maximum keys can be 3, and minimum keys can be 1. Except root node. See, these rules are not applied on root node. Root node can have maybe 2 children. Root node can have 0 child. Root node can have 1 key. Like that. Now the one main important property of B plus tree is what? In B plus tree, the data. See, this given data. This data is stored only in leaf nodes. Right? And in B-tree, data is stored in leaf node as well as in internal nodes. But here, the data is stored only in leaf node. Now, what is stored in internal nodes in B plus tree? Only the pointers, so you can see the indexes. Fine, indexes to the data, which is stored in the leaf node. Those indexes are stored in internal nodes. And second important point is, the data which is present in leaf node, those data is present in a form of linked list, right? All the leaves are connected with a link with each other. I'll show you how, when we are creating a B plus tree with this example, right? So these are the two main differences. I'm going to make a proper video on B plus tree properties and how B plus tree are different from B-tree. In this video, I'm going to tell you how data is to be inserted in B plus tree, right? See, and B plus tree, see, B-tree is what? It was a generalization of BST, binary search tree. So data in parent node, right? So the data to the left of parent is always less than parent, and data to the right of parent is always the greater than that parent. So that property is also followed in B-tree as well as in B plus tree. So now let us start. See, here order is 4. So initially node is there, tree is empty. So we are going to construct a node, you can say, right? And that node can have maximum how many keys? 3 keys. So that node can have maximum 1, 2, 3 keys, and maximum children can be 1, 2, see 1, 2, 3, and 4. So in between these 4 links, only 3 keys are possible, right? So now see, first number is 1. Insert 1. So we can insert 1, right? So next is 4. Now where 4 is to be inserted, split from this node, then right. Another thing I have told you up. So in this is what? 20 and 21. See, to the right of 31, 31 and 42. Then in the leaf node, you have to just fetch the root block, this block, and only one. Hi guys, welcome back. In this video, I'm going to discuss with you some properties of B-tree, and after the discussion of these properties, I'm going to take an example and we'll create a B-tree with help of.
Hi students, welcome back. Let's continue with the database management system. The next topic in the subject is the B plus tree in database management system. So what is this B plus trees? It is a data structure that we know that, which is used to implement implementation of database index. So just like the data structure, so here in the database, these B plus trees are used to implement database indexes. So that's why we call it, it's one of the multi-level indexing, so which is used for the database indexes. It is a balanced binary search tree. It follows a multi-level index format. So that we already know that, which is following the multi-level index format. In B plus tree, leaf nodes denotes actual data pointer. Whatever the leaf nodes consisting of, that leaf nodes is give the actual data pointers. Okay, so it also ensures that all leaf nodes has to remain in the same length height. All leaf nodes remains at same height. Okay, so the leaf nodes are linked. Here one more concept, when compared to the B trees, in the B plus trees, the leaf nodes are linked using linked list. Therefore, it can support the random access as well as the sequential access. So not only the sequential access, it also supports the random access. So the when compared to the B trees, B plus tree occupy a little more space than B tree, because it also has the information regarding the linked list. One node is connected to the another node, so that node is already repeated. So that we see, anyhow we'll see in the example. Let's have a look on the characteristics of the B plus trees. Characteristics. Data records are only stored in the leaves. Means the leaf nodes. So whatever the leaf nodes consisting of, that is the actual data pointers. And its internal node stores just keys. keys. So the key values will be stored in the internal nodes. So I'll show you the example here, how the B plus tree structure will be like that. Suppose if I take, this is my root node. Suppose this is the tree. Okay, so this is the root node. So here let me take, this is the key value. Let me take the k is the key, 3 is the key value. So the left hand side of the key value, let me take here a 2 value will be stored. So this x, whatever it is there, this is the x value, that is less than key value. Okay, and here whatever it is there, the right side of the 3, you consider 3, 4. So which is the x value is greater than or equal to the k. And here it should be 5, 6, 7, something like that. Okay, and here one node, the leaf node is connected to the another leaf node. Okay, so these are the leaf nodes, and this is an internal node. Internal node. So all leaf nodes are interconnected with each other. Why these are connected to one another? Because for faster access. For faster access, we are connected all the leaf nodes by using the interlist. So the keys are used for direct search to the proper leaf. So why we are using these key values? The key values are used for the direct search rather than searching for each and every element. With the help of the key, we can directly go to that particular internal node, and from that internal node, we can easily find out the leaf node. Okay, so this is exactly the concept of the B plus trees. So now let's see an example on this B plus trees. Then you'll understand what exactly it means. Okay, so let me take one example. So I'm taking an example. Then 2, 4. Let me take the first page. 2, 4, 7, 10, 17, 21, 20. So constructed in B trees. So let me take my key consisting of only 3 values. Okay, 3 values it can insert. And right hand side should be send it to here. Now it's consisting.
Hi guys, welcome back. In this video, I'm going to discuss with you some properties of B tree, and after the discussion of these properties, I'm going to take an example and we'll create a B tree with the help of that example. Okay, so let's see. What is B tree? It is also known as balanced M-way tree. Here M means order of that tree. See, if it is given that create a B tree of order 5, then here M is equal to 5. That is M-way tree. That tree would be 5-way tree. Okay, it is also known as, you can say it is generalization of BST. BST is what? That is binary search tree. Okay, I hope everybody know what is binary search tree, in which a node can have more than one key and more than 2 children. See, in case of binary tree, or you can say binary search tree, binary means what? 2. So every node can have at most 2 children. That is case of binary. See, at most 2 children. I'm not saying exactly 2 children. 1 children ho sakta hai, 0 ho sakta hai, but at most 2 children ही होंगे. That is the meaning of binary tree or binary search tree, you can say. But in case of B tree, these are not binary tree, we can say, because children इसमें क्या हो सकते हैं? More than 2 children. 1, 2, 3, 4, 5, 6. कितने भी children हो सकते हैं? It depends on the value of M. We'll discuss it with the help of an example. Plus one more thing is, every node can have more than one key. See, key means what? Let us take one example of binary search tree. Suppose this is binary search tree. Here we have 10, here we have 5, here we have 15, here we have 3, here we have 6, and here we have 11. Suppose, okay. So this is known as node, and the value is known as key value, or you can say key. One node is there, one node, and node. Every node is having how many keys? Only one key. See, here the key value is 10, that is key is 10. So every node can have only one key. But in case of B tree, a node can have more than one key. यहाँ पे B tree अगर आप create करोगे, यहाँ पे 10 के साथ आप 15 भी लिख सकते हो, 17 भी लिख सकते हो, and that would constitute one node only. So every node can have more than one key, and how many keys would be there in this node? It would depend on the value of M. Okay. Now the next point is, it always maintains the data in sorted data, or you can say in ascending form. We'll discuss it with the help of an example. Next is, all the leaf node must be at the same level in B tree. Same level means, see, हमने एक tree देखा था, this suppose this one, and this one. Okay, obviously this is also a binary tree, or you can say binary search tree. अगर लिखोगे तो यहाँ का values दे सकते हो. This one is leaf node, this one is leaf node, this one is leaf, this one is leaf, this one is leaf. But every leaf node is at different level. Suppose यहाँ पे 0th लेते हो आप, ये 1 level, ये 2, this one is 3rd, this one is 4th. ठीक है? So every node is having at different level. But in B tree, every leaf node is at different level. It is possible in binary trees. But in case of B tree, every leaf node must be at the same level. वो same level पे ही होंगे. Example लेंगे, in that case, then it would be clear to you. Okay. Now, if we have order M, then a B tree of order M has the following properties. कुछ properties होंगी अगर उसका order M है. M means वो 3, 4, 5 कुछ भी हो सकता है. It would be given in example. See, order M है in that case. Every node has maximum M children, at most M children. Okay, every node. इसका data structure B tree का कुछ ऐसा होगा node का. See, like this. Every node can have more than one key, like key 1, key 2, key 3, and up to K. Suppose key N. Okay, and it would also be having some pointers, or you can say links, and these links would be to the children. You can say these are children of this node. Okay, so every node has maximum M children. Suppose a B tree of order 5 is given. Suppose M की value is 5. So every node can have maximum how many children? Only 5 children. 1, 2, 3, 4, 5 links could be there. Okay, see. K1, K2, these are information, key values 1, 2, 3, 4, and 5. These are children, or you can say subtrees. At most 5 children. Okay, and minimum children कितने हो सकते हैं? Maximum children M हो सकते हैं for every node, root के लिए भी, leaf के लिए भी, and all the internal nodes. Okay, minimum children कितने होंगे? Obviously leaf node का child कोई नहीं होगा, that is means 0 children. For root node, minimum children would be 2. It's only for that root node. Okay, root node होगा अपना starting में, नीचे अपने क्या होते हैं? That leaf nodes. तो इनके बीच के जितने भी node होंगे, that are known as internal nodes. And all the internal node would have minimum how many children? M by 2, and this one is ceiling. See, ceiling. I hope everybody knows. Suppose यहाँ पे लेते हैं m is equal to 5, then 5 by 2 ceiling. 5 by 2 means 2.5. इसका अगर ceiling लेते हो in that case what would be the answer? That is 3. 2.5. It is real number, point में value है तो इसके ऊपर का जो इंटीजर होगा just ऊपर, that would be 3. Ceiling means ऊपर वाला लेंगे 3. अगर ये floor होता in that case 2.5 की अगर floor value लेनी है, floor means नीचे वाली value, then you would have taken that 2. Okay, ceiling means 3. 5 by 2, 2.5 का ceiling क्या होगा आपका? 3 होगा. Children हो गए maximum m children, minimum children, leave का कुछ नहीं होगा, root के लिए minimum 2 and all the internal node will have m by 2 and इसका ceiling. Now next is how many keys would be there? This keys children का हो गया अपना काम. Now key कितनी होगी? That would be every node has maximum m minus 1 keys. मतलब जितने children होंगे उनसे एक की कम होगी. Maximum m children है तो m minus 1 की. Suppose यहाँ पे अपने पास कितने थे? 5. 1 2 3 4 5. तो की कितनी होंगी? k1 k2 k3 and k4. Maximum key would be these are links k1 k1 k2 k3 k4 for every node. Now minimum keys would be for root node, minimum key would be 1. See, it's for root node. Minimum की कितनी हो सकती है? 1. Except root node, for all the nodes, जितने भी node होंगे except root node, all other node would have minimum keys m by 2 ceiling minus 1. इसमें आप confuse नहीं होना है. Minimum children would be m by 2 का ceiling and minimum keys would be m by 2 ceiling minus 1. यहाँ भी क्या होगा आपका एक minus maximum keys m minus 1 or maximum children would be m. Okay, one more thing about B tree. See, in this case, in these type of trees, the insertion would be always in the leaf node. Okay, अगर कोई value आपको insert करनी है, that value would be inserted in these type of trees. The insertion would be always in the leaf node. Okay, अगर कोई value आपको insert करनी है, that value would be inserted in the leaf node only. आप root में insert नहीं करोगे, आप उसको leaf node में हमेशा वो insert होगी. Okay, so in next video I'll take one example and I'll discuss how to create B tree using these properties. Till then, bye bye. Hi guys, in this video we are going to create a B tree. Okay, and in the last video I have discussed all the properties of B tree. So let's start. See, suppose we have one question that is create a B tree of order 3 by inserting values from 1 to 10. आपको values insert करनी है 1 2 3 4 5 6 7 8 9 10 and order क्या होगा tree का आपका 3. Order अगर 3 है तो m की value would be 3. Okay, now see, m value is 3 तो maximum कितने children हो सकते हैं for every node? 3 and maximum key कितनी हो सकती है m minus 1 that is 2. ये आपको याद रखना है. These are properties of that B tree. Now see, now start करते हैं insert करना. We have hi guys, in this video we are going to create a B tree. Okay, and in the last video I have discussed all the properties of B tree. So let's start. See, suppose we have one question, that is create a B tree of order 3 by inserting values from 1 to 10. आपको values insert करनी है 1 2 3 4 5 6 7 8 9 10 and order क्या होगा tree का आपका 3. Order अगर 3 है तो m की value would be 3. Okay, now see, m value is 3 तो maximum कितने children हो सकते हैं for every node 3 and maximum key कितनी हो सकती है m minus 1, that is 2. ये आपको याद रखना है. These are properties of that B tree. Now see, now start करते हैं insert करना. We have this node. इसमें कितनी values हो सकती हैं अपने पास? Maximum key कितनी हो सकती है for every node m minus 1. ये आपको प्रॉपर्टी से पता चल, जो प्रॉपर्टीज मैंने लास्ट वीडियो में डिस्कस की थी, आई होप आपने वीडियो देखी होगी. दैट इज 3 1 दैट इज 2. तो मैक्सिमम कीज वुड बी 2, 1 and 2, key 1 and key 2. नाउ 1 सबसे पहले इंसर्ट होगा, आफ्टर दैट 2 वुड बी इंसर्टेड. ओके, एंड सी वन मोर पॉइंट, दीज वैल्यूज आर ऑलवेज इंसर्टेड इन सॉर्टेड ऑर्डर. ऐसा नहीं होगा कि 2 आपने 1 से पहले इंसर्ट कर दिया, बिकॉज दिस की 1 की 2 है तो की 1 वुड बी लेस देन की 2. अगर यहाँ पे की 3 होगा देन की 2 वुड बी लेस देन की 3 एंड ग्रेटर देन दिस की 2. ओके, नाउ सी, नेक्स्ट इज 3. यू आर सपोज टू इंसर्ट 3. But if you insert 3, in that case, the value, how many keys are there in this node? 3 keys, but maximum key कितनी हो सकती है? 2. So that is overflow condition. Now you have to split it. अब उसमें split कैसे होगा? See, always जब node split होता है, that वो कहाँ से होता है आपका? Median part, or you can say the middle element. Middle element calculate होगा पहले कहाँ पे है, and that middle element would go 1 level up from this node. 1 level up. Okay, not down. हमेशा B tree grow करेगा upwards, because leaf node हमेशा क्या होंगे? At the same level. नाउ अब ऐसा नहीं होगा कि 1 2 यहाँ पे 3 इंसर्ट किए बिना ही आपने यहाँ का मिडिल एलिमेंट फाइंड आउट कर लिया. सपोज 1 या 2 कहीं से भी आपने उसको मीडियन एलिमेंट कैलकुलेट करके उसको ऊपर भेज दिया. नो, 3 को आप कंसीडर करोगे, उसके बाद ही आप इसका मिडिल एलिमेंट कैलकुलेट करोगे. नाउ द मिडिल और द मीडियन एलिमेंट वुड बी 2. नाउ दिस 2 वुड बी 1 लेवल अप. सो आपका ट्री क्या बन जाएगा? 2. 2 के लेफ्ट साइड में क्या होगा आपका? 1, बिकॉज 1 इज लेस देन 2. ओके, इट इज सी BST बेसिकली, जनरलाइजेशन ऑफ BST. तो बाइनरी सर्च में क्या होता है, यहाँ पे जो रूट होगा उसके लेफ्ट साइड में वैल्यू वुड बी ऑलवेज ईदर लेस देन और इक्वल टू दिस वन, एंड राइट साइड में वैल्यू वुड बी ईदर इक्वल टू और ग्रेटर देन द रूट नोड. ओके, नाउ 2 के राइट साइड में क्या होगा आपका? 3. 2 है ये बॉक्सेस, बिकॉज मैक्सिमम की कितनी इंसर्ट हो सकती है? 2. नाउ द नेक्स्ट की आपको जो इंसर्ट करनी है, दैट इज 3 तक इंसर्ट हो गया. नेक्स्ट इज 4. रूट पे सी इंसर्ट हमेशा कहाँ से होगा? लीफ नोड से, बट देखेंगे हम कहाँ से? रूट नोड से. 4 इज ग्रेटर देन 2 तो यहाँ पे जाएंगे, बट आप यहाँ पे इंसर्ट नहीं करोगे. ऑल्दो दिस प्लेस इज एम्प्टी, यू कैन इंसर्ट, बट हम इंसर्ट इसमें नहीं कर सकते बिकॉज वैल्यू कहाँ पे इंसर्ट होती है? हमेशा लीफ नोड में. सो इसके राइट पार्ट में नीचे जाएंगे, दैट इज 3. 3 से भी बड़ा है 4 तो यहाँ पे इंसर्ट हो जाएगा बिकॉज इट इज लीफ नोड. इसके नीचे कुछ भी नहीं है तो यहाँ पे आपका 4 इंसर्ट हो गया है. ठीक है, नेक्स्ट वैल्यू इज 5. अब 5 अगर इंसर्ट करनी हुई तो वो यहाँ पे इंसर्ट होगी बिकॉज 2 से ऑलवेज 5 एलिमेंट 5 से 7 का we'll find out to create a a B tree probably will नोड से 4 फिटिंग greater than 4 तो 5 आपकी कहाँ पे आएगी, यहाँ पे आएगी, बट मैक्सिमम कीज कैन बी 2 एंड हियर वी हैव 3 कीज, सो दिस नॉड वुड बी वी हैव टू स्प्लिट इट. स्प्लिट कैसे होगा? फर्स्ट ऑफ ऑल मीडियन जो मीडियन एलिमेंट है वो फाइंड आउट होगा एंड देन मीडियन एलिमेंट और मिडिल एलिमेंट वुड गो टू वन लेवल और यू कैन से टू द पेरेंट ऑफ दिस नोड. पेरेंट इसका है ये, तो 4 कहाँ पे चला गया आपका, यहाँ पे जाएगा. ओके, बट टू द लेफ्ट ऑफ 4 यहाँ पे आ गया आपका, कहाँ पे आएगा आपका, here we have 1 see and 3 कहाँ पे आएगा आपका, after 2 but to the left of 4 यहाँ पे आ गया आपका 3 और 5 कहाँ पे जाएगा आपका, right of 4 because 5 is greater than 4 तो इसके right में जाएगा एंड 3 आपके क्या रहेगा, 4 के लेफ्ट में रहेगा बिकॉज ये 4 से लेस देन है, बट 2 से ग्रेटर देन है तो ये 2 के राइट में आएगा, 4 के लेफ्ट में आएगा. ठीक है, नाउ नेक्स्ट वी हैव टू इंसर्ट एज 6. यहाँ पे गए 6 इज ग्रेटर देन 2 एंड 4. ओके, सो ये इसके राइट साइड में जाएगा. यहाँ पे अपने पास है वी हैव लीफ नोड, 1 पोजीशन इज देयर दैट इज वैकेंट, तो यहाँ पे 6 इंसर्ट हो जाएगा. आफ्टर दैट 7 कहाँ इंसर्ट होना चाहिए, वैसे यहाँ होना चाहिए, बट वी कैन नॉट इंसर्ट इट हेयर बिकॉज मैक्सिमम की कितनी हो सकती है 2. नाउ अगेन दिस नोड वुड बी स्प्लिटेड. स्प्लिट कहाँ से होगा, मीडियन एलिमेंट दैट इज 6 कहाँ पे जाएगा, 1 लेवल अप दैट इज टू द पेरेंट. अब 6 अगर यहाँ पे गया, ओके, सो दैट इज ऑल्सो नॉट पॉसिबल बिकॉज यहाँ पे ऑलरेडी फुल है, 2 की हो सकती है और यहाँ पे क्या हो गया, वुड गो टू इट्स पेरेंट. पेरेंट इसका कुछ है नहीं, तो ये आपका 1 लेवल अप मतलब ये दूसरा आपका रूट बन जाएगा. ओके, अब नेक्स्ट ट्री क्या बन जाएगा अपना, ट्री होगा लेफ्ट में क्या है, एस 3 ओके एंड 6 बिकॉज इट इज लेस देन 6. 7 इंसर्ट करना था, 7 आपका कहाँ जाएगा, यहाँ पे right of this one. Okay, now see now we have to insert what, 8 आपका कहाँ इंसर्ट होगा, रूट से 4 से ग्रेटर देन है, यहाँ पे गए 6 से ग्रेटर देन है, बट इट इज नॉट लीफ नोड, वो यहाँ पे जाएगा और 8 आपका कहाँ इंसर्ट हो गया, हेयर ओनली. नाउ नेक्स्ट इज वे के राइट में क्या होगा आपका, लेफ्ट पार्ट वुड बी 7 एंड 8 के राइट में क्या होगा आपका 9. ओके, एंड नेक्स्ट एलिमेंट इज 10, तो 10 आपका कहाँ पे, सी ऑलवेज हमेशा ये कहाँ पे होगा आपका, लीफ नोड में इंसर्ट होगा, तो 10 वुड बी इंसर्टेड हियर. सो दिस इज द बी ट्री ऑफ ऑर्डर 3 एंड द वैल्यूज जो हमने इंसर्ट किए हैं दैट आर फ्रॉम 1 to एंड 5 अगर इंसर्ट करनी हुई तो वो यहाँ पे इंसर्ट होगी, यहाँ पे आएगी, बट मैक्सिमम कीज कैन बी मीडियन एलिमेंट है वो फाइंड होगा, एलिमेंट वुड गो टू 1 का है ये, तो 1 सी एंड 3 कहाँ पे आएगा आपका, आफ्टर 2 बट टू द लेफ्ट ऑफ 4 यहाँ पे आ गया आपका 3 और 5 कहाँ पे जाएगा आपका, राइट ऑफ 4 बिकॉज 5 इज ग्रेटर देन 4 तो इसके राइट में जाएगा एंड 3 आपके क्या रहेगा, 4 के लेफ्ट में रहेगा बिकॉज ये 4 से लेस देन है, बट 2 से ग्रेटर देन है तो ये 2 के राइट में आएगा, 4 के लेफ्ट में आएगा. ठीक है, नाउ नेक्स्ट वी हैव टू इंसर्ट एज 6. यहाँ पे गएगा एंड 3 1 सी एंड 3 कहाँ पे आएगा आपका आफ्टर 2 बट टू द लेफ्ट ऑफ 4 यहाँ पे आ गया आपका 3 और 5 कहाँ पे जाएगा आपका राइट ऑफ 4 बिकॉज 5 इज ग्रेटर देन 4 तो इसके राइट में जाएगा एंड 3 आपके क्या रहेगा 4 के लेफ्ट में रहेगा बिकॉज ये 4 से लेस देन है बट 2 से ग्रेटर देन है तो ये 2 के राइट में आएगा 4 के लेफ्ट में आएगा ठीक है नाउ इज ग्रेटर देन 4 तो इसके राइट में जाएगा एंड 3 आपके क्या रहेगा फोर के लेफ्ट में रहेगा बिकॉज ये 4 से लेस देन है बट 2 से ग्रेटर देन है तो ये 2 के राइट में आएगा 4 के लेफ्ट में आएगा ठीक है नाउ नेक्स्ट वी हैव टू इंसर्ट एज 6 नोट वुड बी स्प्लिटेड स्प्लिट कहाँ से होगा मीडियन एलिमेंट दैट इज 6 कहाँ पे जाएगा 1 लेवल अप दैट इज टू द पेरेंट अब 6 मीडियन एलिमेंट का क्या है और यहाँ से स्प्लिट हो गया 4 2 के लेफ्ट में क्या है अपने पास 4 क्या होगा 4 के लेफ्ट में क्या होगा 2 4 के राइट में क्या होगा यहाँ पे आपका क्या हो जाएगा 6 ओके नाउ सी 2 के लेफ्ट में क्या है अपने पास 1 2 के राइट में व्हाट यू हैव इज 3 ओके एंड आपकी 5 6 आपका ऊपर चला गया 6 यहाँ तो 5 कहाँ पे आएगा आपका लेफ्ट ऑफ 6 बिकॉज इट इज लेस देन 6 7 इंसर्ट करना था 7 आपका कहाँ जाएगा यहाँ पे right of this one okay now see
Hi guys, in this video